Hi, in this video, we are going to see how to solve quadratic equations by completing the square. Okay, to solve any quadratic equation by completing the square, the two algebraic identities are important. Let's consider a perfect square trinomial, that is a square positive 2ab positive b square. Okay, in algebra, whenever we have a trinomial in this form, that is a square positive ab positive b square, it can be written as a square of a binomial, that is a positive b the whole square. There is one more identity, that is a square negative 2ab positive b square. So if you have an algebraic expression in this form, I mean trinomial in algebra in this form, a square negative 2ab positive b square, it can be written as a square of a binomial, that is a negative b the whole square. Okay, when we solve a quadratic equation by completing the square, we should be trying to get the expression in the quadratic equation either in the first form or the second form, so that we can write the expression as a square of a binomial, a positive b the whole square or a negative b the whole square. Okay, let's look at an example. Let me take the quadratic equation, that is x square positive 6x positive 8 equals to 0. Okay, here x square positive. I am taking the x term in this quadratic equation, which is 6x. So I have to write this one as a multiple of 2. That is, I must be writing this 6x in the form of 2ab. So then I'm getting 2 times x times 3. Okay, here x square positive 2 times x times 3. When I compare this one with this, I have x for a and 3 for b. So here we have a square positive ab. Here we have x square positive 2 times x times 3. So what is missing over here? Here we have b square. If I have b square, I can write this trinomial as a positive b the whole square. But here the b square is missing. So when I compare this one and this one, clearly the b is 3. So 2ab 2 times, instead of a we have x, instead of b we have 3. So b square is missing. That means 3 square is missing. So I must need 3 square over here. So for that, I'm adding 3 square. But if I add 3 square, it will change the original stuff. So to adjust the addition of this 3 square, I subtract 3 square. So finally, I'm taking this positive 8 equals to 0. Okay, so here in the quadratic equation, the expression I have on the left side is x square positive 6x plus 8. I have made some changes in this expression because I just want to get a trinomial in the form a square positive ab positive b square. So here particularly I consider the first perfect square trinomial. The reason is, so here the x term is positive. So that's why I consider the trinomial in which we have positive sign for 2ab. Okay, here if I simplify this expression, it has to be equal to the original stuff x square positive 6x positive 8. Okay, let's check it. So we have x square. When I multiply 2 times x times c, that is equal to 6x. And this is 0 pair, positive 3 square, negative 3 square, and positive 8 is over here. So the expression I have over here is equal to this one. Okay, now let's consider the first 3 terms over here. So just compare this one with a square positive ab positive b square. It is exactly the first 3 terms. X square 2 times x times 3 positive 3 square are exactly in the form of a square positive 2ab positive b square. So we write a positive b whole square for the trinomial a square positive ab positive b square. Then what do we have to write for this x square positive 2 times x times 3 positive 3 square? So it's very simple. For a we have x, and for positive 2ab we have positive x 2 times x times 3, we have to take positive sign. So because for 2ab we have positive sign, and instead of b we have 3. So x positive is whole square. So this is the square of the binomial we write for this trinomial. And negative 3 square means it's negative 9, positive 8 equals to 0. Some students may get confused with this negative 3 square. So because we have square, so some students will take this negative as positive. Actually, it's not correct, because this square is applicable only for 3, not for the negative sign. If you have negative 3 whole square means, so the square is applicable for both negative and 3. So this negative will become positive when you apply this square. But here in our problem, we have square only for 3. So it's not for, it's applicable only for 3, not for the negative 9 and negative 3, not for the negative sign. Okay, now x positive 3 the whole square. When I combine these two values, negative 9, positive 8, it will just become negative 1 equals to 0. Okay, now I'm adding 1 to both sides to get rid of the negative 1 over here. When I add 1 to both sides, there's negative 1, positive 1 will cancel out. I get x positive 3, the whole square equals to 1. Okay, x positive 3 whole square equals to 1. Okay, now to solve for x, I have to get rid of all the values around the variable x. So first, let me get rid of the square. For that, I'm taking square root on both sides. Okay, so here the square root and square root cancel out. So whenever I take square root for a number, always will have positive and negative sign in front of the square root. So we have x positive 3 is equal to positive or negative. Square root of 1 is just 1. So we have x positive 3 is equal to positive 1 or x positive 3 equals to negative 1. Okay, now to solve for x, I have to subtract 3 from both sides over here. I get x is equal to negative 2 and I subtract 3 in this equation also to solve for x. So positive 3 negative 3 will cancel. I get x is equal to negative 4. Okay, I got the two values of x, negative 2 and negative 4. Okay, let's look at one more example. X square negative 8x positive 12 equals to 0. Okay, here, as I told you in the previous question, x square negative. So this is x term always has to be considered for 2ab. So we have to write this one as a multiple of 2. So 2 times x times 4. So we can write this 8x as 2 times x times 4. So now we have to compare this one with a square negative 2ab. So for a we have x, for b we have 4. So we need b square. If I have b square over here, we can write this trinomial as a negative b the whole square. So because 2ab is negative, I have to use negative sign over here. So what do we need? B square is missing. So instead of b, what do we have in our problem? We have 4. Okay, let's do that. So 4 square we need. I'm adding 4 square. To adjust the addition of 4 square and subtract 4 square, at last I'm taking the value positive 12. Okay, now let's simplify this expression. It has to be equal to the original stuff. So x square 2 times x times 4 is 8x. And this is 0 pair and we have positive 12. So the expression what I have over here is equal to the original stuff. Okay, so for this trinomial, that is for the first 3 terms, x square negative 2x times 4 positive 4 square. I mean, these 3 terms are in the form of a square negative 2ab positive b square. So we can write the square of the binomial a negative b the whole square. For a, we have x. And for b, we have 4 the whole square for the first 3 terms. Since 2ab is negative, I'm taking negative sign over here. Then negative, the value of 4 square is 16 and positive 12 equals to 0. So x negative 4 the whole square. When I combine these two values, I'm getting negative 4 equals to 0. I'm adding 4 to both sides. So because I have to get rid of this negative 4, x negative 4 the whole square equals to just positive 4. So to get rid of the square, I'm taking square root on both sides. When I take square root on both sides, the in front of square root, I'll have positive or negative sign. On the left side, the square root and square root cancel out. I get x negative 4 equals to positive or negative. We know that the square root of 4 is just 2. So I get x negative 4 equals to 2 or x negative 4 is equal to negative 2. Okay, now I can add 4 to both sides to solve for x. So I get x is equal to positive 6. And I'm adding 4 to both sides in the second equation. I'm getting x is equal to, so negative 2 positive 4 will become just positive 2. So I get two values for x, 6, 2. Okay, so here we have seen two examples. In both the examples, they are when I look at the coefficient of x, it's a multiple of 2. So we can easily write the x term in the form of 2ab. Like if I consider the previous example, I have 6x. So I can write 6 is a multiple of 2. So I can write this one in the form of 2ab. That is 2 times x times 3. In the second case, 8x is also a multiple of 2. So it can be written in the form of 2ab. That is 2 times x times 4. What if the coefficient of x is not a multiple of 2? Okay, let's look at one more example to understand that stuff. X square positive 5x positive 6 equals to 0. Here, when I look at the x term, the coefficient of x is not a multiple of 2. So how can I write this one in the form of 2ab? Okay, so for this one as well, but anyways, I must write the x term in the form of 2ab. For that, I'm writing 2, and always we have x for a, so 2a. And now I have to write the value of b, so that the simplification of this one must be equal to 5x. So what value should I take for b so that the simplification of this one is equal to 5x? So it's very simple. I have to take 5 over 2. So when I multiply 2 times x times 5 over 2, this 2 will cancel out, and I get 5 times x is 5 is equal to 5x. Okay, now this is in the form of a square positive 2 times a times b. So what is missing? B square is missing. Instead of b, we have 5 over 2. So if I want b square, I have to add 5 over 2 the whole square. So to adjust the addition of this 5 over 2 the whole square, I have to subtract the same stuff. And at last, I have to take this positive 6 equals to 0. So this is 0 pair, it will vanish. And the simplification of this one is 5x, and we have positive 6. So this expression is equal to the original stuff. Always we have to make sure of this. Okay, now the first three terms are in the form of a square, positive 2ab, positive b square. We have x for a, and we have 5 over 2 for b. So whenever we have a trinomial in the form a square positive b positive b square, we know that it can be written as a positive the whole square. So here a has to be replaced by x and b has to be replaced by 5 over 2. Okay, let's do that. So x positive 5 over 2 the whole square negative. You can simplify this one. So we have square for the fraction 5 over 2. So this can be distributed to numerator and denominator. So we get 5 square over 2 square. 5 square is 25 and 2 square is 4. Positive 6 equals to 0. So we get x positive 5 over 2 the whole square. Okay, now to simplify this one, negative 25 over 4 positive 6, we have to multiply this integer 6 by this denominator 4. Once we are done with this multiplication, we can take this 4 as a common denominator. So we can write this one as negative 25 positive 20. 6 times 4 is 24 over 4 equals to 0. So x positive 5 over 2 the whole square. When I simplify negative 25 positive 24, it will be negative 1 over 4 equals to 0. Okay, now I can add 1 over 4 to both sides because my aim is to solve for x. If I add 1 over 4 to both sides, I'll be getting x positive 5 over 2 a whole square, which is equal to 1/4. Okay, now to get rid of the square, I have to take square root on both sides. So here this square root and square root cancel out. So here I'm taking a square root on the right side. I'm taking square root for number 1/4. So the sign in front of the square root has to be positive or negative. So I'm getting x positive 5 over 2, positive or negative. Square root of 1 is just 1 and square root of 4 is just 2. So we can write this equation as 5 over 2 is equal, x positive 5 over 2 is equal to 1 over 2, or x positive 5 over 2 is equal to negative 1 over 2. Okay, to solve this equation, we can subtract 5 over 2 from both sides. Then I'll be getting x is equal to 1 over 2, negative 5 over 2. And here we have the same denominator for both the fractions. So we can write this one as 1 over 5. I mean 1 negative 5 over 2. So it becomes a negative 4 over 2. Finally, it is simplified to x is equal to negative 2. Okay, now let's solve the second equation over here. The same thing, to get rid of this positive 5 over 2, I have to subtract 5 over 2 from both sides. Then I'll be getting x is equal to negative 1 over 2, negative 5 over 2. So I'm getting x is equal to, so negative 1, negative 5 over 2, which becomes negative 6 over 2. Okay, so negative 6 over 2 will become negative 3. So I got two values for x. The first value of x is negative 2 and the second value of x is negative 3.